All right, so this is the lesson for 5.4. Now that this student just walked in, it took you like 12 hours to come back from water. I'm not going to say the name. And we're going to, this is a test for 5.4. This is a live lesson. We're going to send a shout out to Senna that is not here. So 1, 2, 3, woohoo. So 1, 2, 3, woohoo. Right. So Senna, by the way, you will be seeing this shortly. You're so lucky because Monday you can get to have like an online math test on 5.1, 5.3. 1, 2, 3. You see, everybody wants to take the test, Senna. So have fun. And you also have the homework for 5.4. 1, 2, 3. So this is, we're going to deal about the sum and the difference formulas in trigonometry. They're kind of important for evaluating angles that are not the basic angles. Let me talk to you about the basic angles that we know and you have to have memorized. 0, of course, pi over 6, pi over 4, 4 pi over 3, pi over 2, pi, 3 pi over 2, 2 pi, etc. All everything we have memorized in the unit circle. Also in degrees, so you need to know the 0, 30, 60, 0, 40, 30, 45, 60, 90, etc. But what happens when you have different kind of angles? That's what we will learn today. So these are the angles that, these are the formulas that we are going to use. If you were here in class, you will see I have posted there at the back of the classroom when I'm pointing. They are very important. Usually I post it all around. What I want you to do as an exercise, so you actually write them, I want you to actually copy these 6 formulas down. And let's try to, as a new, so you can memorize it. So you have a couple of minutes to copy these formulas down. The first formula is the sign of the sum. The second formula is the sign of the difference. The third one is the cosine of the sum. The fourth, the cosine of the difference. Fifth, the tangent of the sum. And sixth, tangent of the difference. I'm going to ask you for a huge favor, which is important. I want you to make clear distinction between your u's and your v's. Because from experience, I know that sometimes they look the same, so make sure that your u's and your v's are clearly identifiable. All right? Are we good with this?
Yeah.
Okay. So I see an easy pattern that the cosine of the sum becomes a subtraction and the cosine of the subtraction becomes an addition. That's a good thing to remember. Let me show you again that the cosine of the sum becomes a subtraction and the cosine of the difference becomes a sum. On the cosine formula you have the cosines first, the sines second. On the sine formulas, the sum and the difference stay sum and difference, and you do sine cosine of the first and sine cosine of the. So these are formulas that if you're taking a quiz, obviously you can use it at home or here I will provide this to you. All right? Mm-hmm. Right? Yeah. So let me move on. And you can come back on this lesson and copy it, finish your copying. So let's deal with this question. You have find the exact value of sine of pi over 12. Pi over 12, we haven't memorized that. However, Bernardo, you can see that pi over 12 is the difference of pi thirds minus pi fourths. Because as a fraction, that becomes 4 pi over 12 minus 3 pi over 12 is 1 pi over 12. So what you do is you're going to do sine of pi over 12 is the sine of the difference. The sine of the difference becomes sine of the first cosine of the second minus cosine of the first sine of the second. Sine of pi thirds is root 3 over 2. Cosine of pi fourths is root 2 over 2 minus cosine of pi over 3 is 1/2. Sine of pi 4 is the square root of 2 over 2. And then you multiply 2 times 2 is 4. You have root 6 minus root 2. So you're lucky because you get to practice this. I will provide, even though you have the formulas for your notes, I will provide this formula down here, and you can do the problem. You have some time to do the problem. Sena, you should pause this video and you should do it also. So I'm assuming if you guys are not here, so you're not going to be here the next lessons, but that's going to work for you probably, right? Okay, that's good. And if you have questions, you can always contact me with this, okay? All right, so I think from what we discussed, you're going to have to be kind of intelligent in terms of how to deal with pi over 12. So let me get a nice color. So I have cosine of pi over 12 is going to become cosine of how am I going to express pi over 12?
Cosine pi thirds plus pi fourths.
Kind of pi thirds minus pi over 4. And then that formula, the subtraction of the cosine, the cosine of the difference will become a sum, Della.
Yes.
So it's going to be the sum. So I have cosine of pi thirds, cosine of pi fourths, minus now the sines, plus the sines, sorry. Sine of pi thirds, sine of pi fourths, and now you can use your unit circle, which I know you know it very well. So cosine of pi thirds is 1/2, and then cosine of pi fourths is root 2 over 2, plus sine of pi thirds is root 3 over 2 times sine of pi fourths, which is root 2 over 2. So you get a fraction over 4, and you get on the top 1 times root 2 is root 2 plus root 6. And that's the exact answer. How do you guys feel about it?
I don't know which pi to turn into. Like,
How do you go from pi over 2 to pi 3 and pi 4?
That's the
Because
question.
you're trying to use only the ones we know. So we know how to use pi over 3, pi over 4, pi over 6, and pi over 2 and pi. So you're trying to make a combination using them. So for example, if you are only allowed to use dimes and nickels, all right? And I want you to make the number 25. What would be a possible answer?
2 dimes and a nickel.
All right. How did you know how to do it?
Wait,
It's
so
exactly
you
the
use-
same kind of thing.
Can you use pi over 6 and pi over 2?
How?
I don't know.
You can use a lot of combinations. Yes.
So
The
just
answer is yes.
multiples?
Yes. Correct. Excellent. Correct. So next one. The same thing can work with degrees. So easy. Look, we have cosine of 75. How can I express 75 with the basic angles? It's 30 plus 45. All right. So you have cosine of 30 plus 45 is cosine of the first, cosine of the second, minus the sum becomes the subtraction, sine 30, sine 45. You fill in from the unit circle that you already know very well the values, and you find square root of 6 minus square root of 2 over 4. So practice this for sine of 75, and I will give you the formula so you can use. Also, Ryan, you said correctly, is multiples. And for both of you, Ryan and Alex, the idea here is experience. If you do the homework that I have assigned, it gives you most of the possible situations that I will ask you. So I think sine of 75, it's clearly that sine 75 degrees will become of sine what, Declan? Bernardo.
Sine of 45 plus 30.
That's it. So it's now the sine of the sum, and it's the first formula, the sine of the sum. You get sine of the first one, sine of 45, times cosine of 30, plus you reverse them. Now sine of 30, cosine of 45, if I'm not. So sine of 45 is root 2 over 2. Cosine of 30 degrees is root 3 over 2. Plus sine of 30 degrees is 1/2. And then cosine of 45 is root 2 over 2. So I hope you realize that the unit circle is something you need to really know very well in situations like that. So you get root 6 plus root 2 over what, Partha?
Root 2 over 4. Or 4, right?
4, correct? Excellent.
Sure, is it?
No. Are we good? Right? And now we'll go to something that is a little more advanced, but based on what we have done up to now. Let's look at this. Find the exact value of sine u plus v, given that sine of u equals 4/5, where u is between 0 and pi over 2, which means we are in quadrant 1 easy. And on cosine v is negative 12 over 13, where v is in quadrant 2. When you do this situation, you have to do at least 2 pictures. I want you to understand this, that we're moving into problems Emma, with 2 angles. So that's why you see 2 pictures. I have a U picture and a V picture. That's important. So let's do the U picture, which is the U picture in quadrant 1. So I'm in quadrant 1 and I have that sine of u equals 4/5. Sine is opposite over hypotenuse. So 4 is the opposite, 5 is the hypotenuse, and I use the Pythagorean, a form of the Pythagorean theorem, and I find square root of 5 squared minus 4 squared, so 25 minus 16. 9 square root of 9 is 3. So I find that the adjacent of angle u is 3. Similarly, I have cosine of v is negative 12 over 13 in quadrant 2. So I'm in the diagram of on the diagram for v, I have that cosine is negative 12 over 13. Cosine is adjacent over hypotenuse. So I have adjacent 12 or negative 12, hypotenuse 13. So I have to find the opposite side. So it's 13 squared, 169, minus 12, which is 144, is 25. Square root of 25 is 5. So the opposite, Ethan, is 5. So that gives me, I can summarize now. I can summarize on the first one that I know that sine of u is 4/5. But similarly, I know that cosine of u, what is cosine of u? Easy here. What is cosine of u? Cosine is adjacent over hypotenuse, so that's it, it's 3 over 5. And let's go to the u one. It was given to us that cosine of v equals negative 12 over 13. So what is sine of v? Let me ask Ethan. What is cosine sine of V? Sine is opposite over hypotenuse. What is it?
5/13.
So 5 over 13. Excellent. 5 over 13. So now that I have the sine and the cosine of the u and the cosine and the sine of the v, I can just use the formula, and the formula, the sine of the sum here, formula the sine of the sum is the sum of the sine, cosine, cosine, sine. I plug in the values and I find negative 13 over 65. So you can practice this, finding cosine of u plus v. I'm going to give you the formula to use. So before you even start, as Ryan would say, you need to draw the two diagrams.
Sounds like a shit.
Sorry?
That sounded like a shit.
Yeah, I did. So u is in what quadrant?
1.
Okay, very good. And v in quadrant 2.
2.
You agree, Janine?
Yes.
Good. So quadrant 1 for you. And I have sine is opposite over hypotenuse, so it's 12 over 13. So here, so I get 13 squared minus 12 squared equals 25 squared equals 5. So I get 5 for this. So, and I get that sine of u, which was given to me, sine of u is 12 over 13. But what is cosine of u? Cosine is adjacent over hypotenuse, which is 5 over 13. That's perfect. So we have this part. So this is my u diagram. So this is not optional. You need to do these pictures. Let's do the second picture, which is the picture for u, which is, as Ryan said, is quadrant 2. I think it was Ryan. No, it was Partha. So V was cosine. They give me cosine, which is negative 3/5, which is cosine is adjacent over hypotenuse, so negative 3, 5. So for me, do you all see what is the opposite without me doing it?
Yes.
Della, you're okay? You can see the opposite? What is it? Janine, what is the opposite here? So I have negative 3, 5.
The opposite.
Yes, the opposite here.
9.
It's 4. It's a 3, 4, 5 triangle. So immediately it's a 4. So if I have that sine of u, no, sorry, cosine of v equals negative 3/5, what is sine of v? What is sine of v? Sine is at opposite over hypotenuse, which is, Ethan?
4 over 5.
4 over 5. Good. So we have everything we need. So now it's just a matter of using the formula. So I have cosine of u plus v is cosine of u cosine of v minus sine of u sine of v. So I get cosine of u is 5 over 15 times cosine of v, which is negative 3 over 5, minus sine of u, which is 12 over 13, times sine of v, which is 4 over 5. So I can see that, sorry, it's 5 over 13. So what is 13 times 5? 13 times 5 is 50, 15, so it's 65. And the top is 3 times negative 5 gives me negative 15, negative 15, and negative 48. 48 and 15, can you do this? Can you do this? So the bottom is definitely, or I can do it. 13 times 5, 50, 65, and the top, it's going to be, as I said, negative 15 minus 48. So minus 63 over 65. Are you guys alright with this? Alright, good. So let's see what is the next one. So right, for now I'm going to stop here